the concept of id3 algorithm by solving a very simple problem. Well, how a decision tree looks like. So if I have to form a decision tree of should I accept a new job offer, then it looks like this. Here we can see the logic and how it is making the decision, and it is very simple and clear. But what is a decision tree? Well, a decision tree is a tree where each node represents a feature or an attribute, and each link represents a decision rule, and each leaf node represents an outcome. A decision tree is a supervised learning algorithm. Now we have a couple of algorithms to form a decision tree, but here we will focus on id3 algorithm that uses entropy function and information gain. So now let's see this problem. We have been given a data set and we have to make a decision tree that predicts whether tennis will be played on the day or not. Now let's observe the data set. Here we have 5 attributes: outlook, temperature, humidity, windy, and play tennis. This play tennis is the class attribute that is the final outcome, and its value depends on another 4 attributes. Now to make a decision tree, we have to first choose the root node. So how we will choose the root node? Well, the attribute that can best classify the training data, you can use this as the attribute of root node. But how to choose the best attribute? So from here we will use id3 algorithm. Well, id3 algorithm has 2 important concepts, that is entropy function and information gain. Entropy tells about the uncertainty in dataset. What does that mean? It means the number of positive and number of negative example. For example, if we have equal number of positive and negative example, then the entropy will equals to 0. If we have only positive examples or only negative example, then the entropy will equals to 0. Now next comes is information gain. So information gain is the difference in entropy before and after splitting the dataset on attribute A. What does that mean? This is our dataset. Initially we will calculate the entropy for this entire dataset. Next we will calculate the entropy for this particular attribute outlook, then temperature, then humidity, then windy. Then we will sum up this. This is known as this average information. And this average information we will subtract it from the entropy of the entire dataset. So that is known as information gain. So like this is information gain and this is the entropy. Next that comes is id3 algorithm concept. What does id3 algorithm says? So the first step is compute the entropy for the entire dataset. As I have told, you have to calculate the entropy for the entire dataset. Now for each and every attribute in the sense this outlook, temperature, humidity, windy, for each and every attribute, now you have to calculate the entropy and then average information entropy, and then what you have to do? You have to calculate the gain and then pick the highest gain, that will be your node, and we have to repeat this process until we get the tree. How we will know that we get the tree? That is, the last node should be a leaf node. Okay. So now let's see the problem. This is the entire dataset which we had. The first step is calculate the number of positive examples and number of negative examples. So there are 9 positive examples, that is yes, 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 there are 9 yes, and 5 negative examples, 5 no's, and the total is 14. So if you have to calculate the entropy, then just look into the formula how it was, minus p upon p plus n, where p represent positive and n represent negative. Make sure here the logarithmic function has base 2 and p upon p plus n, that is a positive value, it's not a negative. Similarly, n upon p plus n log to n upon p plus n. Now substitute all the values, that will be minus 9 upon 9 plus 5, 9 positive examples and 5 negative examples. You will substitute all the values and the value you will get is 0.940. So this 0.940 is the entropy of entire data set. So that's why it is represented as entropy S. Next we have to do is, we have to calculate entropy for each and every attribute. So first I am taking outlook. So outlook has how many values? Sunny, rainy, overcast. 3 different values we have. So we have split our dataset according to those 3 values. So here when outlook is equals to sunny, when outlook is equals to rainy, when outlook is equals to overcast. So like this we have now 3 separate tables. Now in these 3 separate tables we will see for sunny how many positive values are there. So for sunny we have 2 positive values, so write 2. Now for negative examples, how many values are there? 3. So we have 3 negative examples, and then we will calculate the entropy. How we will calculate the entropy? By simply substituting the values in the formula. Similarly for rainy, how many positive values are there? 3. So write 3. How many negative values? 2. So entropy is 0.971. And similarly for overcast, all the values are positive. So 4 and 0. Now to calculate the entropy, see this is the formula. Just substitute the values, p value, n value, and you will get the respective answers. Now the next step was to calculate the average information entropy. Based on the previous formula, for the attribute outlook, this will be the formula. That is positive examples of sunny plus negative examples of sunny upon p plus n. Here p plus n represents the number of positive examples and number of negative examples of the entire data set. Okay, it's not about this particular attribute we are talking, but instead we are talking about this entire data set. Okay, so here p of sunny plus n of sunny upon p plus n, and entropy outlook is equals to sunny, then outlook is equals to rainy, so p of rainy plus n of rainy upon p plus n, and then when outlook is equals to overcast, then p of overcast plus n of overcast upon p plus n. So what will be the value? How many positive values of sunny are there? So in sunny we have 2 positive values, and how many negative values? 3. So like this we will write 3 plus 2 divide by total number of positive value, that is 9, and total number of negative value is 5. And similarly, what is the entropy of outlook is equals to sunny? So that we have seen, that is 0.971. So we will write 0.971. Similarly, when outlook is equals to rainy, so how many rainies are there? So for rainy we have 3 positive and 2 negative, and the entropy is 0.971. So just write the exact same values over here, and then for overcast, so the value which we got is 0.693. Now the next step that comes is you have to calculate gain. And what is gain? Gain is equals to your total entropy minus whatever the information you have got. So entropy of S is 0.940 that we have calculated in the first step. So gain of outlook will be 0.940 minus 0.693 is equals to 0.247. Make sure you try to solve the problem while watching the video itself, so that you can have a better understanding of what we are doing over here. Now the next attribute which we have is temperature. Again, the temperature has 3 values, that is hot, mild and cool. So for hot we have one table, then for mild, and then for cool. Again similarly, what we will do for hot, the number of positive examples are 2, the number of negative examples are 2, and the entropy will be 1. As I have said, whenever the number of positive and number of negative examples are same, then the entropy is equals to 1. Similarly for mild we have 4 positive examples and 2 negative examples, so the entropy is 0.918. And for similarly for cool we have 3 positive examples and 1 negative example, and the entropy is 0.811. You can calculate the entropy simply by substituting the values in the formula. If you have any doubts, then you can just comment down or you can just ask. Now the next step will be obviously to calculate the information entropy. For this, again the same thing, how many values temperature can have? Hot, mild and cool. According to that, P of hot plus N of hot upon P plus N, then P of mild plus N of mild upon P plus N, and P of cool plus N of cool divided by P plus N. You can get the respective values from the table over here, substitute all the values over here, and then you will get the information as 0.911. Now what was the next step? Next step was to calculate the gain. So again, gain is equals to entropy of S minus I of attribute. How much the entropy was there? 0.940. So what will be the gain? Gain will be 0.940 minus, what was the value? 0.911 is equals to 0.029. This is the gain of the temperature. Now what is the next attribute? Next attribute is humidity. Humidity has 2 values, that is high and normal. Now again we will form a table according to normal and according to high. Then we will calculate the number of positive example over here is 3, number of negative example over here is 4. This is for high, that is this table. And similarly for normal, there are 6 positive examples and 1 negative example. So entropy over here is how much? 0.591. Now again you will calculate average information entropy, and how you will calculate? Humidity is equals to high, so number of positive high plus negative examples of high upon total P plus N, and plus entropy, humidity is equals to normal, and positive normal plus negative normal divided by total P plus N. Substitute the respective values and you will get 0.788, and in this case the gain will be entropy minus I attribute as similar, 0.940 minus 0.788, and the value will be 0.152. Only now we are left with last attribute, that is windy, and in this windy we have again strong and weak. So we will make the table with respect to strong and weak, then we will see how many positive and negative examples are there, and then we will calculate the entropy. Now after that, again average information entropy. So windy is equals to strong, so positive strong plus negative strong divided by P plus N, and again windy is equals to weak, so positive weak plus negative weak upon P plus N, and as you know P and N are the values from the original data set, and this P weak and N weak are from this table. So now again substitute the values and the answer will be here 0.892, and then again calculate the gain. So gain will be 0.940 minus 0.892, that will be equals to 0.048. Too much, right? So many 4 attributes are there and then you have to calculate so much. And at last we will compare all the values, that is here outlook 0.247, temperature 0.029, humidity 0.152, wind is 0.048, and the highest value is outlook. So we have to pick that value, and this will be our root node. So our root node is outlook. So how a decision tree will look like now? We have a root node as outlook, and this outlook have 3 decision rules, that is sunny, overcast, rainy. But in the overcast, all the values are yes. So you can directly make a leaf node over here, and thus it doesn't require any further splitting. But for sunny, we have variable values, like for some value it is yes, for some it is no. So still we cannot say that whether sunny will give yes or no. So thus we have to do further splitting for sunny as well as rain. So now we will form again new data set. This will be with respect to sunny and this will be with respect to rainy. We have to perform all the operations on sunny and then we have to perform all the operations on rainy. I know it's too much, but just a little bit and then it will be over. So first of all we will take for sunny. Okay, there's just a little mistake, but okay. The number of positive examples are how much? 2, and number of negative examples are how many? 3. So just total is 5. So now the P and value changed. Before that it was 9 and 5, but for this now we have 2 and 3. Okay, so now the entropy over here will be, just substitute the values 2 upon 2 plus 3 and all the values, and you will get entropy as 0.971. Make sure you don't make the mistake here. The P and N values are 2 and 3. This is like a new data set which you are going to solve. Well, after that you have to calculate again for each and every attribute. So now we will take humidity, but make sure you are taking only the sunny values. Why? Because now we are calculating for sunny. Okay, so you cannot take values from overcast, you have to take values from sunny itself. So that's why when you are forming the table, make sure that you are taking outlook value as sunny and then you are checking humidity and then we will check platelets. So here the same method, humidity, high, normal, number of positive examples, how many positive examples? Only for high, that is 0, and negative examples are 3, so 3. And for normal, number of positive examples are 2 and number of negative examples is there when humidity is equal to normal, that is 0, so entropy will be 0. Again you can calculate the average information entropy. Try to calculate it by yourself, match your answer with the slides given over here. So information of humidity is equals to 0. Now you have to calculate the gain. So what was gain? According to previous formula, entropy minus I of humidity. So how much entropy we got? That was 0.971. And what is the humidity we got? 0. So 0.971 minus 0, that will be 0.971. Similarly, we will calculate for windy. Now again the outlook value should be sunny. Now windy can have 2 values, strong and weak. So according to that, strong, how many positive value? 1. How many negative value? 1. So entropy is 1. And similarly, how many positive value for weak? 1 and negative value 2. So 0.918. Now you will calculate average information entropy, that will be equals to 0.951, and the gain, that will be 0.020. That is 0.971 minus 0.951, that is equals to 0.020. Similarly, you will calculate for temperature. Make sure outlook value is equals to sunny. You have 3 values here, cool, hot, mild. According to that, you form this table, calculate the entropy, then calculate average information entropy, and then calculate gain. It will take a little time, but please make sure you pause the video and calculate all the values and make sure it is correct. And if you have any doubt, write down in comment. Then you have to pick the highest gain attribute from this 3 value. For the temperature we got 0.571, for humidity we got 0.971, for windy we got 0.02. So the highest value over here is humidity. So the next node in sunny, that is after sunny, will be humidity. So it will look like this. We have first outlook, then we had sunny, then in the sunny the next node which we have selected is humidity. Now see, for normal all the values are yes, so I can directly write yes over here, and for high I have 3 values, that is no, so I can directly write no. So it is the pure leaves and we don't need any further expansions. But now the another decision rule is remaining, that is rainy. So it requires further splitting. Now again we have to repeat the entire process for rainy. So now this is the table for rainy. Again, the positive, how many positive values are there? 3. How many negative values are there? 2. Total 5. Again you will calculate entropy. It's the same value, here it comes 0.971. Then you have to calculate at each attribute entropy, that is first of all for humidity. Make sure here the outlook value is rainy, not sunny, rainy. Okay, then calculate the humidity, calculate the table. Number of positive examples are how much? For high it is 1, and again for high negative example is 1. So write 1 1, entropy will be 1. For normal the number of positive examples are how much? 2. Number of negative examples is how much? 1. Thus entropy is 0.918. Calculate the information, that will be how much? 0.951. Again calculate gain, what will be the gain? 0.971, that is this entropy minus the information of humidity. So 0.971 minus 0.951, that is 0.020. Similarly calculate for windy. Again outlook value should be rainy. So for strong, no positive values but 2 negative values, entropy is 0. Similarly 3 positive values, no negative values, entropy is 0. Calculate the information for windy, then calculate gain is equals to 0.971. Now for temperature, same process. Here we have only 2 values, cool and mild. There is no hot. So lucky, you have to just do only two values. You have to find only for 2 values. Calculate the entropies, then calculate the information, then calculate gain, and thus finally the biggest value, that is the highest value, is for windy, that is 0.971. So the next node in rainy will be what? Windy. So the final decision tree will look like something like this. We have outlook. In the outlook we have 3 decision rule, that is sunny, overcast and rainy. For overcast we can directly write yes, but for sunny again you have to check for humidity. If the value is high, then it will be no. If it is the value of normal, then it is yes. And similarly for rainy, we will check another attribute, windy. If windy is weak, then yes. If it is strong, then no. So this was all about decision tree.